Okay, so AVL tree insertions. So let me discuss this topic by using an example so it will be easier to understand. So let's say we have a data set something like, I don't know, maybe let's say 1 2 3 4 5 6 7 8 9 10, something like that. So how do we insert these node, or let's say these data, to AVL trees? So first we insert 1. So balance factor of this node will be 0 because left subtree is 0, right subtree is 0. Then balance factor is 0. Then we insert 2. So 2 will go this side because it must follow the binary search tree properties as well. So the larger values will go to the right subtree. So this node having balance factor of 0, this node having balance factor of minus 1 because right subtree is 1 and left subtree is 0. Then we get 3. So 1 is over here, 2 is over here, 3 is over here. So 3 is 0, 2 is minus 1. Now 1 is minus 2 because left subtree is complete 0, right subtree is having height of 2, which makes the 1 is minus 2 balance factor, because we know the balance factor of that specific node will determine the height of the left x minus height of the right x. So this is the AVL tree condition. Okay. So now we can see this is this specific tree having right order. So we have discussed 4 cases. The first one is left case, second one is right case, third one is left right case, fourth one is right left case. So in the left case we must perform right rotation. In the right case we must perform left rotation. In the left case we must perform left and right rotations. Then in the right left case we must perform right and left rotations. Okay, so this is the right case. So we must perform right rotation over 1. So it will make a tree like this. So 2, 1 and 3. Now the balance factors are 0, 0, 0. You can easily guess that. Okay, now tree get balanced again. So let me insert the next value. So remember that if your tree is unbalanced, you can't insert further more values. First you fix that corresponding unbalance, the corresponding imbalance. Then the tree will get balanced. If it gets balanced, then you can do, or you can continue the inserting. Otherwise you must perform the series of rotations in order to fix the balance of the AVL tree. So 4 will be inserted like this, 3 and 4. So balance factors are 0, -1, -1 and 1. Then 5 is there. Most probably there will be a AVL tree violation again. 4, 5, oh, okay, we have a violation. So 0, -1, -2. Yes, this having -3, but don't write -3 because we already see that we already can see over here we have a violation. So it is not necessary to go to this one. So first let me fix this imbalance. Then we can see other balance factors as well. So again this is right order. So first let's perform right rotation over 3. So it will make my tree like this: 2, 1, 4, 3 and 5. So balance factors are 0, 0, 0, again 0 and -1. See, now it balanced again balanced. Okay, let's insert 6. So 2, 1, 4, 3, 5 and 6. Again, okay, still we are in the safe side or not? So 1, 1, 2, 3, no. Again, we are not in the safe side. So now you can see the balance factor of 2 is invalid. So now what is the order or what is the case that we must consider in order to balance this AVL tree? Here is the condition. So we inserted 6 over here. Okay. So the imbalance seems occurred in which way? It is again in the right case. Don't get confused, it is not the right left case, okay, because we inserted our node to this specific right subtree. So let's say if we inserted some node to this side, then it will make right left case, but in this case we inserted our 6, our new value, to the right subtree, so it must be having right case. Okay, so let me perform left rotation over 2. So this will make 2 to go downside and 1 3 will be attached to 2. So 4 will be the corresponding new root. So now you must be able to see such stuff in your mind, otherwise you will get confused, because rotations are one of the essential thing that you must understand when it comes to data structures and algorithms. So if you still don't get how this rotation works, please watch the previous videos so you will get some understanding. Okay, so now the tree again got balanced. 0 0 0, then 0, this is -1, this is 0. Okay, so let's insert 7. So 4, 2, 1, 3, 5, 6. This is 6. Okay, sorry about that. 6 and 7. So let us consider balance factors again. So 0, 0, not 0, -1, -2. Okay, we got imbalance. So you know this is left case. Sorry, it is right case. So you must perform a left rotation. So same thing we are doing again and again. So I don't think it is very difficult to understand. So again it balanced. So all the balance factors are 0. So just see those in your mind. So let me insert 8 for 2, 6, 1, 3, 5, 7 and 8. Again balance factor seems okay because we are still in the safe side. 0 0 0 and -1. Yeah, okay, then let me insert 9. So most probably we are in trouble. 1 3 6 5 7 8 and 9. Sorry. Okay, so balance factors are again imbalanced. So you know the specific order, right? Right case, so it is left rotation. So let me perform a left rotation. So 4, 2, 1, 3, then 6, then 5, then 8, then 7, then 9. So balance factors are 0 0 0 0 -1 0 0 0 and -1. Okay, so let insert our last value. So 4 2 1 3 and 6 and 5 8 7 9 10. So let me consider the balance factors again. Sorry, -1, 0, okay, see, -2. Again we got imbalanced over here. So you know the specific order. This is again right case. So don't get confused. In this example we got the right case always because I selected this specific example as a sequential order. Okay. So normally you won't get some example like that. Maybe you get some other examples, so you will encounter these three cases as well, these are other three cases as well, but the theory is exact same. So when you encounter some specific case, only you have to consider either left or right rotation. Okay, it's always like that. Always perform left or right rotation according to the particular case, then check the balance factors again. So if it is get balanced, you are done. But if you are not if your tree is not get balanced, you must perform or you must consider another cases as well. Hmm? Sorry. So now, so 6 will be go downside and 5 7 will be attached to the 6. So it will be something like that. So you must be able to see each and everything on your mind, otherwise it is very difficult to write. Okay. So 8, then 6, then 5 and 7 and 9 and 10. So let me consider the balance factors again. So leaves are always 0, these are leaves, and these are 0 again, these are 0, this is 0, this is -1, and our tree is balanced, and we completely inserted each and every data as well. So this is the way how insertion of AVL tree works.